embarrassed to say I had it on this pole. It went way up there as well, but it was getting like the leaning tower pizza, and I thought, well, if we get a storm and the wind blows, it's probably better to blow it into the gutter. Maybe it'll support it a little bit from toppling or cracking all the way down. Each of those boards are 4 feet, so they're kind of overlapping a little bit, but golly, we must be 20 feet up there, guys. I mean, the fence itself is 6 foot. I don't know, I need to measure that and post it a little better for you so we can be more accurate. I got my shades back on the house. They were on quick release here, and it was getting windy, so I had to put them down, but this is the west side of the house, and it allows me to work over here without dying. To replace this tubing with something a little more solid without all these cuts in it and splices. So if we're going to go with something like this on the eve of the house, then we're going to want to probably have something a little more permanent, a little better. But we're still in the testing phase. I haven't decided yet. I just know if I come around the front. Oh my gosh, that's high, isn't it? Whoa. It's almost all the way up there to the top of it. I could attach it to the roof and kind of let it drain down if I decide to go with this long term. I'm hoping you guys have some better ideas. Okay guys, here's the issue. Let's focus in on this part of the video first. What we're trying to do is move water from this IBC tote up to this IBC tote. From the house, draining off the gutter, that big 330 gallon IBC tote, the feeder tote in a sense. I mean, that's 2,700 gallons or pounds of water. And we're trying to move it all the way along the fence line on the west and then along the fence line on the north to get it to an IBC tote that's technically behind the shed here. Okay, now I'm just going to draw a hill that's kind of like this, showing the house going up to the shed, even though it's not exactly going this direction, but you see that there's about a 15-degree elevation rise or lift that I have to attain. So if I were to take a straw that looked like a U, or even a bucket, let's just start out with the bucket, pretend this is the inner walls of the bucket, and I fill it up with water, well, the left side is going to equilibrate with the right side, right? I mean, you're going to see the water level table go right across the top. So if I got rid of the bucket and just put a straw here, a U-shaped straw, and I filled up one side, well, what's going to happen? Of course, the water's going to come up and equilibrate on both sides equal, right? And as I get all the way to the top, both sides are going to be equal, right? Because they're right across from each other. So if I make one just a little bit higher, the water's going to go in, and it's going to dump out on this side, right? So if I were to extend this just a little bit and put the water in, well, the water's going to try to equilibrate, but when it gets over this line right here, it's going to pour out on this side. So that's kind of the same principle we're going to use here. We're going to basically draw a big straw. It looks like a U in a sense, or a V, or whatever, kind of like this. And we know that if we want to get the water all the way up here, 15 feet, we need to raise it just a little bit higher than 15 feet, maybe 15 and a half feet. And then we dump it in, and slowly, on both sides of the straw, the water level rises, kind of horizontal with my pencil there. And as it gets about that level, right there, it wants to dump. So as long as this side's a little bit lower, so what we'll do, we'll just take it like this and put it right into our tote. And now we're able to just keep feeding this from the top, and it'll just dump into the bottom. So it's just gravity. It's just using there's no pumps or anything through the straw. The only pump you need is a little pump down here. That 12-volt pump that we're trying to get the water to go up that little teeny white tube on the outside, just a little bit over this straw, this U-straw in a sense, which is basically half-inch garden tubing or hose. And then once it dumps in, it will slowly equilibrate through the whole system. And if this is just a little bit lower, it'll dump into that IBC tote. So I have to get a board on the fence all the way up there to support the tubing and the little white tube on the outside from the pump that's down in the IBC tote, hooked onto the solar panel that is shown in the video. Hope that makes sense. Of course, we didn't talk about some of the problems. This little pump I've got is only a 12-volt DC pump. And its Hmax, which is this lift, is only 3 meters, which comes out to less than 10 feet. 9.8 or something like that. So this is at least 15 feet, and I'm hoping that little teeny 1/4 inch irrigation tubing and a decent solar panel is enough to push it up there. It worked on the experiment by the shed, when we did it on the little overhang here, maybe 10 feet, but now we've got to go even higher, 15 feet, and I'm not sure I can obtain that. I think it's right on the border of its Hmax. You can go a little over Hmax sometimes. That's the lift height that you're able to obtain. But you're probably stressing your pump a little bit, so we'll be doing some digital multimeter checks and see what our amp draw is and our voltage draw is and our power consumption is to see if we're likely to burn out our pump. Okay, my gut feeling is this pump is not rated for 15 feet lift. Its Hmax is only 3 meters, which is about 9.8. feet. I'm asking an awful lot of that little pump, way over its Hmax. Not sure it's going to work. If it does work, I don't know how long it's going to work. Not only that, but the solar panel is not technically supplying 12 volts. It's supplying more like somewhere between 20 and 14 volts. So I'm overvolting the pump. But that's okay. It's a low-cost pump. It's an experiment. If it works, it's fun. If it doesn't, at least I learned something and I can come up with some other ideas. The little jerry rig I have is not going to be permanent. It's just an experiment. I could technically run some tubing up here and do the feeder tubing into that tubing and then hook into this U and make the U here. So many ways. You could just brute force it, get a electric pump that's really rated much higher and just push it through the tubes all along here, but it's quite a long distance. I would say that's at least 100, 150 feet of tubing that I have to go through just to get it up there along the fence lines. That's going to take some brute force of a pretty powerful pump. So this is kind of using gravity and a little teeny trickle that I might be able to obtain with a much lower power pump. Kind of fun. Experiments are always fun. We'll see how it turns out. So here's that pump. So tiny. You're asking me to do what it says? Are you kidding? Are you crazy? I am, I know. I've got it quick released on here just for the experiment. That's going to have to become soldered with my little solder station here if we're interested in doing this long term. But before I do go to all the trouble to solder something, let's make sure it works. And again, this unfortunately is not matched to the pump. 18 volts. This panel only puts out 5 watts total at the max, and let's see, where is the current? Oh, there it is, 0.28 amps. So the pump, let's see, the pump can take up to 12 volts and 4.8 watts. So they're pretty closely matched at max, but most panels don't get a total output of what they're rated at unless they're totally perpendicular to the sun at noon. So I would say most of the time it's going to be running at least 20-30% of that or lower. I could get a buck converter. I've heard that's the way to do it. Buck converters are little electronic devices that are low cost that you can wire into your panel and your pump, and it keeps the voltage right at 12. You can dial it right in at 12 volts. You can even have some that have current protection. I think the max current here is like 0.4 amps, more or less. If you take watts divided by volts, that's typically the max current, so that's pretty close to 0.4 in this case. So I could probably get a buck converter, solder that into the wiring system. Only bad thing is now I've got more electronic components that could get wet or fail. It sure would be nice to just go direct solar without any extra equipment, but if this fails and this pump burns out, I probably will explore that a little more, the buck converters. Maybe another way is just not to have the panel facing directly perpendicular to the sun. Maybe just have it purposely offset a little bit so that you don't get that full 18 volts or that full current, you know what I mean, a 0.28, you get a little less. And I have a bigger panel that's rated for 0.56 amps, again 18 volts. It's a 10 watt panel that I might end up using because I don't think there's enough power in this guy to pump it the full 15 feet here. We were able to get it on the shed, remember that little experiment on part 1, up about 10 to 12 feet maybe? But this is asking a lot. I just don't think it's going to be able to climb that much. We'll see. Okay guys, my objective is to get that pump into this IBC. I just took the big sock off here. That was, these two things were kind of serving as the filter. And boy was it dirty from the roof. You can see some of the reduce still left. So I think before I put that all back together, I'm just going to drop this nice pump and filter back down here, try to get the air out of that line. Let's see, I turned it upside down a little bit, best I can. Alright guys, I had to raise it up. It was working, but it wasn't quite high enough to get it up to the shed back there. So now we're about a foot over the gutter. I've got it coming all the way behind the fence up here. I feel there's water in the line here to some degree. It's kind of empty there, but I feel it more. Feels like there's some water. It may be that we're just definitely water there. That feels heavy. Maybe that this is about the limit of we're on quite a hill, and that extra 4 feet there is just a little too much for it. Can I go 4 feet higher off the front of the house? Boy, that's really up there. I don't know. Could get a two-way valve here. Put this green hose on it. Open it up and let it fill up to about where the water level is. The water scale level we talked about was probably about halfway up this thing. That way we get half a tank full, and then we could close it and then open up the drip irrigation line again for regular use. But that's not ideal. I kind of wanted to fill the whole thing up. All right, guys, I hate to give up. I know this is insane, but I went ahead and got it closer to the house. And I think it's about 3 feet higher, maybe 2.5, than it was over here on this pole. I kind of had to jerry rig a bunch of old pallet wood, unfortunately. Now I'm getting about to the peak of the house up there. I kind of got the tubing fixed a little bit, got some of the potential leak sites tightened up a little bit, but unfortunately, no sun. Problem with solar, but it'll come back. So once it comes back, we'll go up to the little bin and see if it is indeed transferring the water. Stay tuned. Now, what I probably should do, honestly, is I should probably get rid of this little wood pile here. We don't use it anyway, and put another IBC tote here, a transfer tote, and then I can continue on up the rest of the hill. But that would require 2 solar panels, 2 pumps. So I haven't decided if that's something I'm willing to spend time on. I'd like to just go direct from one to the other. Okay, guys, I got this bigger panel out here. Let's see how many amps she's drawn today. Well, I really like these eco-worthy connectors because I can quickly do an amp check. Again, under 0.3. I don't think we're in the full sun. Let me just move it a little bit. Well, it's really the max I can get. I can't seem to position it any different. So that little pump down in there, he's only drawn 0.256 right now amps, and you remember he's rated it somewhere probably in the 0.35, 0.4 range. Of course, we are throwing in a lot more voltage. Let's see what kind of voltage we're throwing it. It's only supposed to be getting 12 volts sent to it, but let's see what this panel is sending right now. Probably close to 18. Okay, I got switched over to volts. I got 16 coming in. So we'll go ahead and times those 2 numbers and find out what kind of watts we're supplying that pump. Remember, it's a 4.8 pump, so we don't want to go way over on the joules or the watts or whatever. Burn that baby out. So let's kind of add it all up. That pump's down there a little ways. I don't even quite see it there. It's down there a ways, so it's still pumping along. Let's go see if it's also draining out the other side. Hold on. Let's go check it out here. Whoa, it's all wet. Oh my gosh, it's been working. Look at this. That's from the pump down there. I just gotta get a little more sun here going. Guys, it's gonna be a trickle effect. Here, but here it comes, look at that. It's running right on down. All right, guys, after lots of experimentation, just trying to get it just 2 inches higher on the feeder tank. We're finally getting there, man. Is that the sign of success? I mean, this is a low flow. We're late afternoon here, so I'm hoping tomorrow around noon, I can get out here and really see it flowing. I've only got about 0.3 amps going through over on the other side on that pump, so however it is kind of juiced a little bit at 17, 18 volts, so will that shorten life of the pump? Probably. I think what I'm going to do is order a little bit bigger pump. Instead of a $5 pump, go to maybe an $8 or $9 pump. Has a higher lift, just a higher flow rate, and we'll give it a go. But man, I mean, if I just let that trickle all the time whenever the sun's out, morning to night, I'm eventually going to transfer some water, you know, because the bottom line is these tanks don't get a lot of rain this time of year. I took the filter out there, but just to make room. But now it's working. It is absolutely working. I'm sure that's going to slowly fill up. I just love it. We're not even in the midday sun now. We may burn it out during midday sun, but oh my gosh, guys! After being out in the hot sun for 3 days, to finally see it work, it's a thing of beauty. And like I said, I'm tempted to just give it a few days and see what happens here before I take my apparatus down or hook it up to the house. Like I said, just like a little more powerful motor, I think, with a little higher lift. These are good motors, but if it could trickle it that way, it'd be fine. But I think as it drops in the other tank, the level, the pump will go down with it. And we're right on the margin here of getting that to go in. So I can keep trying to raise it up another inch or two on the other side, but yeah, eventually I just need to go higher. And then you wonder if the lift, or no, the Hmax, the Hmax is going to be exceeded with that little pump as it's getting pretty close. But I'm just excited. This is kind of an amateur hour and it is working, so wanted to keep you posted. Okay guys, thanks again for watching and subscribing, and watch for part 2 as I continue this water transfer saga.